You know, some of the most fascinating discoveries are hiding in places we look at every day but never truly see. Things like, for example, an alphabet. What if the very letters we use to write were hiding a secret that's been overlooked for centuries?
What if a writing system wasn't just a tool for language, but was also built with a stunning, almost perfect mathematical balance? Today, we're going to see if that's true by solving a linguistic mystery that's part history, part math, and 100% fascinating.
So our journey starts with the Serbian Cyrillic alphabet. Now, at first glance, it's a beautiful and really logical script. But if we look closer, we might just find a numerical secret that has gone almost entirely unnoticed. Here they are, the 30 letters that make up the script. Each one has a distinct sound, and they're always written in this exact order. From A all the way to Sh, every single one of these characters is a clue in the pattern we're about to uncover. Okay, so like most alphabets, we can break this down into two types of letters. We've got 5 vowels, the core sounds of the language, and 25 consonants. And that number 25 is going to be really important. Keep it in your back pocket.
The key to this whole puzzle lies with those 5 vowels, A, E, I, O, U. I want you to think of them as the fixed rungs on a ladder. They provide the stable structure of the alphabet, and all the other letters, the consonants, are just arranged around them.
So if the vowels are our fixed rungs, what happens when we simply count the consonants that fall between them? Let's actually run the numbers and see what we find.
All right, let's do this. We're just counting the consonants in each segment. As you can see, the first group between A and E has 5. The next little group has 2, which brings our running total to 7. Then the next one adds 7 more, taking us to 14. Then we hit 19, and when we add that final group of 6, we get a grand total of
25. And there it is, 25. Remember that number. It is the exact total number of consonants in the entire alphabet. The numbers add up perfectly. It's a flawless calculation.
Okay, so a perfect mathematical alignment like this, you can't just ignore it. It raises a huge question about how this alphabet was even created in the first place.
So, was this intentional? I mean, did someone actually engineer the alphabet to have this hidden mathematical balance? Or are we just looking at one of the most incredible linguistic coincidences in history?
So we've really got two possibilities here. On one hand, you have intentional design, some kind of secret mathematical elegance built right into the system. And on the other, you have pure chance, just a beautiful accident of how language and writing evolved naturally over time. So, which one is it?
Well, it's time to solve the mystery. And the answer isn't found in some hidden mathematical code, but in linguistics and the real history of how this alphabet came to be.
And the verdict, according to linguists, is in. The mathematical pattern is a beautiful, but almost certainly accidental coincidence. I know, it feels a little disappointing, but the reason why it's a coincidence is just as fascinating as the pattern itself.
The evidence for it being a coincidence is built on 3 key facts: the simple, practical rule the alphabet was designed to follow, the older script that it inherited, and just the way sounds naturally fit together. Back in the 19th century, a language reformer named Vuk Karadžić standardized the modern Serbian alphabet. His goal was super simple and practical, and it's captured by this famous motto. It means, write as you speak and read as it is written. The entire goal was a perfect one-to-one match between letters and sounds, all for linguistic clarity, not for some hidden math.
And this is crucial. Karadžić wasn't starting from scratch. The basic order of the letters was inherited from older scripts. And in those scripts, the vowels, our 5 rungs, were already in historically stable positions. They were anchors. All he did was slot the 25 Serbian consonants into the available gaps based on their sound and tradition, not some kind of grand mathematical formula.
And that, right there, brings us to the core takeaway of this entire explainer. The incredible mathematical balance we found isn't the cause of the alphabet structure, it's a surprising and beautiful effect. It's an emergent property that just happened, arising naturally from a system designed purely for language.
It just goes to show you that sometimes a system designed for simple, practical logic can accidentally produce a pattern more elegant than anything designed on purpose. And it makes you wonder,
What other hidden harmonies are waiting to be found in the world all around us if we just take a moment to look?